Hi, this is Aarti. I'm going to be the instructor for this particular session. So, this session is going to be on TypeScript. In the first session, I'm sure the other instructor he handled a little bit of TypeScript, right? So, he didn't go into detail. He just talked about setting up some of the types, and he talked about what TypeScript was and everything, right? So, before we get started, I'd like to ask a quick question. So, does everyone in here know JavaScript? You don't have to know everything, but until maybe the DOM, that'll be. Yeah, okay, great. So, basics. Basics as in, do you know how DOM works, Alan? Okay, you don't know that. Okay, okay. Okay, that's fine. Okay, so Mark says he doesn't know JavaScript. So what I'll try to explain certain things while I conduct the class. Okay, so Mark, if you have any questions, you can ask me, and I'll clear that for you, right? Because the thing is, Java's TypeScript it's a superset of JavaScript. So yeah, okay, fine. So you are a programmer, right? So in that case, most of these concepts would be. Okay, so let me get started. So I understand that you've been given an introduction to TypeScript already, so I'll just skip through all of those quickly. So as you know, TypeScript it's JavaScript for application scale development, mainly because of mainly because it's strongly typed. It has object oops, and it's a compiled language like the uh, other languages like Java, C, and C++. So mainly because of that, you can use it for uh, big applications, unlike JavaScript, which breaks a little because it has a lot of basic errors. Okay, and it's JavaScript. Okay, so the thing is, you can in your .ts file, which is what we'll be using to write our TypeScript code, you can write pure JavaScript code and it would work perfectly well. But TypeScript, it just has a little bit of enhancement. Okay, additional features, if you will, and those additional features can be combined with the basics of JavaScript to create a completely new language which will help us in application scale development. And the purpose of this particular course, right, Angular, it uses a TypeScript. So that's why I'd like to go a little bit in detail into TypeScript in this particular course, because the next in this particular session, because tomorrow's session is going to be on the fundamentals of Angular. So we'll be looking at a lot of Angular based topics, and we'll be you know you'll have to create a small app at the end as well. So it's better if you know TypeScript very well beforehand. Okay, so all of that is fine. So we'll be covering a couple of things. I understand that you haven't actually handled the installation yet, so I'll tell you how to install TypeScript into your system, and then we'll talk about variables and data types. And there's functions and interfaces and classes, and finally there's also classes come with your access modifiers, and there's also your namespaces. I'm not going to go into modules right now because we will look at modules in our Angular session. So right now I'll end at namespaces. Okay, so that's an extra topic. So all of these things, it's portable. You can use it in pretty much any device, and all of those things that you know. So all of this, I'll leave you to look at all of the theory parts, because I want to focus completely on the programming aspect in this particular session. Okay. All right. So let's get into installation first. So I understand that you haven't actually covered installation, right? So I'll show you how to do that. Okay. So to start off, you'll need to. Do you everyone has a node installed in their system, right? Yes. Okay, great. So if you don't have node installed, then I'd ask you to go to I'll just type this in the chat. Okay, there's a Node.js. Just search for Node.js online, and you'll get the website nodejs.org. Okay, and you can just download that, and you'll have Node installed in your system. So if you don't have that, you can do that, because we'll be installing TypeScript via our npm package manager. So next, what I'm going to do is I'm going to open the command prompt. So I'll share the screen again. Okay, so I've already installed TypeScript in my system, so I'll just tell you how to do this. So you can install it globally or locally for your particular file, um, but it's better off if you install it globally, because then you can use it for any project you want. So this is it. So npm install g TypeScript. Okay. So once you click enter, it'll get installed. And after that's done, you can move on to your Visual Studio Code, which is, let me move on to that. Okay. So I'm using Visual Studio Code. You can download that from online as well. I think all of you have it. If you don't, you can tell me. I'll tell you where to find it. Okay. All right. So I'll be using this, and it's a very simple software. So in my case, I already have a folder prepared. So I have a TypeScript example folder prepared in here, and I just had to go to files and open the folder, and I selected the folder I wanted, and that's that. Okay, so and I got this folder right here. Okay, so and in here you need mainly you need two files. Okay, so you don't really have to worry about your sample.js right now, or package.json for that instance. You can so I can just delete all of those, because we don't really need that. And tsconfig.json, we won't be talking about that right now. I'll talk about that in the next session. Okay, so it's more like if you have any, if you have any knowledge of any framework in JavaScript, then you know that you need these JSON files, and they have the dependencies, and you can set a lot of conditions in here, right? So right now we won't talk about that. So mainly, if you're following along with me, go ahead and create an index.html file, okay, a standard file, and right now, just place your source file as sample.js, or whatever your TS file is, the corresponding JS file, okay? Because TS, it can't be compiled, as you know, it can't be read by your browser. It can't. So you need to transpile your TS files into JS files, and that's how. And that JS file is going to be read by your browser, and you're gonna get the output. Okay, that's how it works. So this you don't really need right now. So I'll just comment that out. Okay. So this is all you have to do. And I already have a terminal running. So if you've used Visual Studio Code before, you know that you can just go to terminal, new terminal, and you'll have a new terminal in here. And I already have something running here. And if I want to close it, I just have to press Control C or Command C if you're using the Mac, and just type yes. And where is that? Okay. And that particular command would actually terminate. Okay. So right now I just need a sample.ts file, as I just showed you. And I told you, right, your JavaScript and TypeScript are pretty much the same. So TypeScript just has a little bit more features than JavaScript, but very important features, and that makes all the difference, yes, but a little bit more. So if you think about it, you can just do a console.log and say hello world like this, and that's pure JavaScript, right? And it'll work as well. So, but if I try to run this as it is, I'll get an error, because there's going to be nothing in my sample.js file. So actually, when I get started off, what will happen is, let me just go ahead and delete it. So when I just start off, I'll just have this index.html and the sample.js, right? I wouldn't have anything else. Okay, so this so you have to first transpile this TS into a JS. So what you'd have to do is you'd have to use the tsc command. So in some computers, the tsc command doesn't work, so you can use the tsc.cmd command. So both are the same, so it works exactly the same. So tsc.cmd, and just specify the file name that you want transpiled and what you want it transpiled into. Generally speaking, you'd probably just want the same file name for your TS and JS file. That's convention. So in that case, what you would do is you don't really have to specify sample.js and sample.ts separately. So you can just say tsc.cmd sample, which means that please convert or transpile the sample.ts file into sample.js file. Okay, so what would happen is right now there's nothing to convert, actually it's pure JavaScript. But what would happen is do you know about the ES 2015 and before? Do you know about all of that? ES6, ES5, all of that, all of those versions of JavaScript? Yes. Okay, so one second. Okay, so as you know, ES6, there's not a lot of compatibility in all of the browsers, mainly the legacy browsers, the old browsers, right? So they don't have a lot of compatibility with ES6. So it was released in 2015, but the version before that, the ES5 version, which was used globally, which has compatibility throughout all of the browsers, now it will convert your TypeScript file into that version, the ES5 version. Okay, ES5. Right, so let me just it's just too big. Okay, so it'll convert it into the ES file, and you'll have a new sample.js file created. So if you just use this command, okay, so let me just press enter in here. It's going to take a little bit of time. In the meantime, there you go. So you have your sample.js file right now, but as you can see in here, it's pretty much the same. It's the same code because we didn't do anything different in here. Okay. Now, if I'd like to run this, I can go to my index.html and right click and open live server. Okay. If you're new to Visual Studio Code, once you download it, you can actually go to your extensions part in here, and you can search for certain things. You can search for Babel ES6, ES7, and then you can search for just make a note of all of these things. Okay, make a note of all of these three extensions that I've installed, especially this live server extension by Ritwik Day, because this is what we'll need to open up a development server to look at our output while developing our code. Okay. All right, so let me just open my live server right here, and I'll share the screen again. There you go. Okay, so if I look at the console, if you are new to JavaScript, to reach the console, you'll have to click on these three button this button in here, and then go to more tools and developer tools, and in here you'll have a lot of options, elements and console. You'll have to go to the console. I've made it big so you can see it through the screen. Okay, I've just increased the size. So there you go, we have our hello world in the console. So console.log, as you can see from here, it basically logs things to that console. So you can use it for testing purposes and things like that mainly. Okay, so on the other hand, if I try to write some ES6, let me go back to my sample.ts file in here. So if I try to write some ES6 code in here, so let and const, all of these are ES6 code, right? So let creates a variable, but you can change the value of the variable. So let's say a is equal to 5 or something like that. Okay, now if you compile it again, so you have to first save it obviously, and then if you compile it again, tsc.cmd sample like this, then what will happen is there you go, it gets converted into var. So I looked at the last session. I believe the other instructor, he actually taught you about let var and const. So I'm not going to go into too much detail into that. So I'll just maybe talk about that via the PPTs. Okay. So var is an ES5 convention, ES5 variable declaration syntax, and it just converted into that. So as I said, it converts ES6 into ES5 and also TypeScript into ES5. Okay, so it can be read by all the browsers. So let's go back to our PPT now so I can talk about the types and everything. Okay, I talked about all of this. So as per the ES 2015 standard, we have three ways of declaring our variables. There's your let, your const, and also your var. But mainly nowadays, we just use our let and const in JavaScript because it's more it's more easy, and I'll show you why. There is your block scope with let and const. So mainly we just use that. Okay, now the var type, it's been used for years, and that was there before let and const came in. So you just declare var and the number and the variable name, and the variable naming convention is pretty much the same with same as the other languages. So you can start with an underscore or a num or a letter, but you can't start with numbers. And you can only have you can look it up online actually. So but for TypeScript, the naming convention is same as JavaScript, and JavaScript is there's just a little. I think from the other languages, the only difference is a little like you can. I think you can use the dollar symbol and things like that. So you can just look that up. And the main difference between var is if you know functions, anything that you declare, a var variable that you declare within a function, it cannot be used outside of a function. That's the main difference. So if you have any questions in any of this, if any of you are new to programming or JavaScript in general, or if any of this is confusing, please while I teach, please stop me and ask me questions. Okay, so I'm trying to make it as beginner friendly as possible, but it's a little difficult. So if you ask me questions, then I'll know. Yeah, okay, great. Okay. Okay, so mainly var the main focus of on var is it has function scope. So anything that you create within the within a function, any if you create a message variable within the function, if you create that outside of the function as well, now these two message variables will be completely same. Okay, so there's your function scope. Now next, now let keyword as it was introduced with your ES15, and it has a block scope. So you have your if and all of those blocks, like anything that's within a flower bracket, that's your block scope. So and const, it has block scoping as well, but the only difference is you cannot it's immutable. You can't change its value once it's declared. So use it for anything that's not going to be changed, like your ID number or any identification or something like that. Okay. And now let's talk about the types. So you must, I'm pretty sure he actually talked about all of these things. So this is how you can set up your types. So let me just show all of these first. So you can set up your number type, you can set up your string type, and with your string type, you can you have your templates just like just like in ES6, and I think he stopped at the arrays type, right? So so let me start. Let me just quickly show you those types again, and we can continue with the rest of it. So the main use of TypeScript is that you can make it a strongly typed language. Now, if any of you know any of the other languages, then you know that you can actually declare types while creating variables. You can make them string. You can, like, if you say str, the variable name, you know that the compiler knows that it's a string, and it wouldn't let you assign a number value or a boolean value to that particular string because it knows that. But in JavaScript, there is no facility to let that happen. So you just say let num is equal to 5, right? But you can assign num to a string 5 and it would still work. But right now in TypeScript, I'm getting an error, but that's because of type inference. I'll talk about that. But in JavaScript, you wouldn't see the difference at all. But in some cases, you need things to be of a specific type. For example, let's say one of your, I don't know, one of your forms, okay, it needs a phone number. Now that has to be just a number, or it's an ID number. That has to be a number, right? So you can't accept strings in that instance. Okay, maybe you're doing something with that number. Maybe you're doing a calculation with that number. Okay, and if you if the user doesn't send you a number, you need to send an error message, because otherwise, let's say you're getting a number from the user and you're multiplying it with 10 or something like that. Okay, so if the user by mistake sends just hello, okay, in the input, then how can you multiply hello with 10? You're going to have a problem there. Okay, so you're going to get not a number. So instead of that, while compiling, if the user gets an error, then they'll know that they've made a mistake, they'll correct that. So that's one of the main uses of TypeScript. So instead of doing it like this, I can just say number. Let num is equal to number. So every time I try to assign a string to this, or for that instance, a Boolean value to this, or any value at all, it could be even an array. Okay, anything at all, it's going to give me an error message. When I compile, I'm going to get the error message as well. But in your Visual Studio Code, it's very programmer friendly, so you'll get the error message here itself. It says type string is not assignable to type number. So you've set a type in here. So what JavaScript doesn't do, TypeScript does it for you. Okay, so just like that, you can specify other types as well. There is your string. And as I'm pretty sure you know, you can use the template, one in the left side corner of your keyboard. You can use that to include variables directly into your string. So number is, I'm just it's just an example. Okay, so you can do things like this. And I want to give you a tip in here before I move on. It is very inconvenient to when you keep compiling, transpiling every time you make a change, right? So instead of that, you can set up a watch command in your in the current terminal, in the terminal that you're in. So every time there's a change, it gets automatically updated. So the only difference is just a hyphen and W. I'm not sure if you can see that. Okay, I'm pretty sure you can see that now, right? Okay, so hyphen W. So this would set up a watch command which watches for any change in your sample.ts file. And it keeps converting that everything to JavaScript. See, and you'll also get any errors every time you save something in your TypeScript file. So right now there's no errors, so 0 errors. Now, if you go to your sample.js, you'll notice that everything has been converted to ES5, and none of the type checking is in here, and this is just a normal string concatenation, and there's no template strings because it's not ES5. Okay, so JavaScript, it just simplifies everything back to what your browser understands, but all of the checking, everything, it happens while the transpiling happens from your TS to your JS. Okay, so it catches everything beforehand. So, and also you can set a Boolean, and if you change it to anything other than Boolean, you'll get an error that says that's quite common. So it says number is not assignable to type Boolean, right? Yep. And also there is this thing called type inference in TypeScript. So setting everything up like this, it's very inconvenient, right? So what TypeScript does is, while you assign it the first time, so if you assign num is equal to 5 the first time, then TypeScript infers that this particular variable is a number. It's going to have a number. Now, if you try to assign something else, it'll act from that inference. So it has already set the type of num as a number. So it'll say type boolean is not assignable to type number. On the other hand, if you just declare something and then assign later like this, then type inference does not happen, because right now TypeScript is confused because it doesn't know what you've assigned. The assignment has to happen in here if you don't want to set up types but still want to specify types to your compiler. Okay, so if you don't do it like that, then there's going to be no type checking. It's going to accept everything. Okay, so that's called type inference. All right, so now let me move on to the other parts. Okay, now for arrays. Okay, so you must, if you know, you must already know what arrays are. Arrays are just a set of elements, and generally, most arrays, they are of a specific type, right? So you can set that up as well. So there are two ways to set up arrays in your array type in TypeScript. So one of them is just specifying the type, like array of numbers, array of a string. So if it's an array of number, then number and then square brackets, or you can specify the array object, and then within your brackets like this, you can say number, so which means it's an array of number. Okay, so I'll show you an example. So okay, so let's have an array list. Okay, and let's specify that it's going to be an array of numbers, so 1 2 3, whatever. It can be any of those things, and you can change the values of your list. So if I set list of 2 to be 5, I'm not going to get any errors in here, no problem at all, because it's still a number. But if I set a list of 1 to maybe a string, then it's going to say type string is not assignable to type number, because this is supposed to be an array of number. Okay, so that's how you do that. But in some cases you might want more than one type in here, right? So you might want to show, I don't know, you might want both the string type as well as the number type, maybe in our example. Okay, let's try how to do that. So let's have another variable in here called info, and within your curly braces, what you not curly braces, okay, within your brackets, what you can do is you can specify the types you want in this particular array. Okay, in my case, I want both number and string. So if you want both number and string, then you can specify it and divide it. Separate it by this pipe symbol, like there's just one pipe symbol. So string or number. So this basically means that this info array can have either a string elements or number elements or both, and all of that is fine. And of course, end that with your brackets, or your square brackets. Otherwise, your compiler wouldn't know that it's supposed to be an array. And in here, you can make this into anything, and all of that is going to work. Now, if you try to set, I don't know, if you try to set one of these as Boolean or an object or something like that, then you're going to get an error because, oh, sorry about that. Okay, then you're going to get an error because, it's not assignable to type string or number. Okay, so whatever you've set, that has to be maintained. Of course, if you're probably wondering, you can do the same with You can do the same with a variable, normal variable as well. So you can set this to be a string or boolean like this. And then if this is a string, it's going to work. If you change it to a boolean, it's going to work. But if you make it a number, then you're going to get an error because it's not string or boolean. Okay, so you can do this. You can set multiple types in your variable as well, and you can actually just go ahead and create a type. So there is and I can make it something like this. Okay, you can create uh, a type. Okay, I'll call mine SNB, maybe SBN, or mul. Okay, I'll call my mul. Okay, to specify that it's going to hold multiple types, and within here you can specify the types that you want. There you go. Okay, you can specify this, and that would mean that this type is for this. It contains this. So instead of specifying the entire thing again and again in any of the variables where it's needed, you can just go ahead and just specify mul in here. Okay, now our array can actually have a boolean as well because that's inside of mul, and in here as well, if that's what you want, you can just specify mul in here. Now you can um, assign a number to that. That'll work as well because it has all three. Okay, and as you can see, every time I save, it's getting recompiled, right? So far, is there any questions? Okay. Okay, great. So let me just move on to the other parts of it. When do you use multiple types? Okay, well, it depends on what your program is about, actually, if you think about it. Okay, let's see. I don't know. Maybe in certain cases, I might want both numbers and strings as well, right? So it actually depends on your program. So in a real world scenario, I'll have to think about it a little. I don't know. Maybe it's a text box. Maybe it's an input box which can, let's say you have an input box. It's getting a message maybe. Okay, and you can accept anything. You can accept both a string and a number in that particular input box, right? But you can't accept things like boolean or any of the other types like the never the avoid or undefined or anything like that. Okay, so it can be either a string or a number. So in that case you can set the type to string or number like that. So does that make sense? It actually depends on your use case. Okay, next let's look at objects. So if you know JavaScript, you already know that objects, um, and in TypeScript as well, you can create objects and you can actually specify the type of the objects and type of the property. So you can specify that the variable is supposed to be an object, and you can specify the types of each of those properties as well. Okay, you can, and then later you can just assign property value pairs. As you can see here, I have, yes, 1 second. Okay, great. Thanks, Mark. Okay, so in here I have an object, right? So we have objects. So I want to create a student object. So I want to specify that this variable is supposed to be an object. So what I do is I just place a colon in here, just like I would with any in any type declaration. But in this case, I'll need to specify the type of each of the property. Okay, so in here I'm creating three properties: roll number, name, and total, and I'm specifying that each of these have the types number, string, and number. Okay, and then in the next line of code I can assign the value of those properties. Now the thing is, now once you set up your this is more like a blueprint, right? So once you set up your object and your property values like this, you can't change it. So you really do need all these properties, and they need to be of these types. If you make any change at all, you're going to get an error. So let me just type this up and show it to you so you can see it for yourself. Right. So I'm going to set this up as a type object. Okay. So instead of just specifying that it's a number type or something like that, I'm going to specify it like this. And immediately I'm not going to assign, but you can go ahead and do the assigning here as well. I'll show you how to do that. But right now I'm just setting up the type. So my object is going to have three properties: the roll number property, and the name property, and the total property, like this. Okay, so now I've set up the type. So while looking at this, your compiler is going to know that this is an object with all of these properties, and these properties have these types, and it's going to look for the same in the value, in what's going to be assigned to this object. So there are two ways of doing this. So you can immediately assign as well. Okay, right now you're going to get an error because there's a lot of missing properties. See, that's what I said. Once you specify all these properties in your type, you have to have those properties inside your assignment. Okay, so you can specify the values of those. The roll number has to be a number, right? So I'm making it 1001, and then a name is John, and total is 490, like this. There you go. Okay, so now I don't have an error because I've replicated all of the properties exactly. But if I try to add something else in here, maybe like this, okay, then I'm going to get an error because type, whatever we just created, okay, it's not assignable to the type that we just set up. So age does not exist in the type. Do you get this? So it has to have just the same number of properties. Okay, and also the types have to be the same. So if I make total a string right now, it's going to give me an error because type string is not assignable to type number. Okay, so that's how you can declare your objects. Let's see if it can. Nope, it can't. You have to actually specify the exact things. Now if you wanted to have less, if you want options, I'll teach you how to do that. Say now it says property total is missing, but on the other hand, I was going to talk about this later on, but on the other hand, if let's say you want total to be an option. Okay, so you can either have total, not have total. So but let's say these two are compulsory but total is an option. In that case, you can specify uh, a question mark right after the property name, like this. Then your compiler would consider this. Let me assign this afterwards as well, so there's no confusion. So this is your type, this is your assignment. So you can specify a question mark after your property, and then if you don't have it in your assignment, there's no problem. Okay, on the other hand, I can go ahead and reassign something to this. Now um, let's say I want to change the entire thing. Okay, and this time I want total. That's going to work because I've said that it can either be there or not be there. Let me look at the questions now. Okay, okay. All right, so let's move on to the next part, okay? Okay, so there's this is an extra feature in TypeScript. Actually, you don't have that in JavaScript. So you have something called tuples. Okay, um, now remember our array types. We just generally set our type as either a number or a string, or you can have both and things like that. But we can't specify the type of each of our element, right? There was that problem. So now you can do this. So if you specify the type like this, okay, so you have your tuples where within your square brackets you can specify the type of each of the element in your array, and you have to maintain the same thing. So for example, if the first one has to be a string, the second one has to be a boolean, third one has to be a number, like that. Okay, and remember the optional values that we talked about just now in our object. So we have that in our tuples as well. So since these are each values, okay, you can specify that certain things are optional, and that's completely fine. Okay, so you can miss that out and there won't be any problem. But the thing with this is, try to keep keep the optional values at the end. Okay, this is an array, right? So it's not like your object where you have the property name to reference. In here you don't have anything. So if you keep your optional ones in the middle, then your compiler is going to get confused. So if a value has to be optional, keep it at the end. Now, you might wonder why you need something like this, right? Let me give you an example. So we have our standard example that I have in here as well. So let me just show that first, and then let me talk about why you might need something like this. So this is my example. Okay, and now I can. Second one is Boolean. The third is supposed to be a number. The fourth is again a string. The fifth is again a string, and all of that works perfectly. Okay, end it properly, and all of that works perfectly. No errors at all. I've saved it. I don't think I have an error. Yeah, no error. Okay. So and it works similar to your normal array. So you can do a console.log of just text, or of let's say one maybe, and you can look at your console output. Let me share that, this one, right? So you can look at your console output and you're going to get the same thing. See, that was I asked for the second element, right? So it's true, so I'm getting that chat. So all of that is pretty much the same. And also you can specify one of these values as optional. So if I say the last string can be optional, in that case, I can get rid of the last part and it's still going to work, right? Now, on the other hand, why would I need something like this? See, for example, let's say we have a student array with a lot of information. So let's say that this array, the first one has to be the ID, the second one is going to be the name, the third one is going to be the total, the fourth is going to be the age, and so on and so forth. So in that case, you might want the exact type specified. Okay, so you don't want to change the type. So you'd say the first is ID, right? So you'd have to specify the first type as a number. The second is name, so the second type is string. Third is again going to it's going to be the total, so it's again number. The fourth is age, is going to be number, and so on and so forth. And you can have any of these as optional as well. For example, I can say that the age can be optional. Of course, for such an example, you're better off using objects because you can specify uh, the property name. But just an example. So in that case, I can say 101 and name is Santosh, and number. What was the next one? I think it was total. So it's 450, let's say, and age is 16. and no errors, right? You can miss out on age and you'll still get no errors. Yeah, that's the thing. Okay, I can actually show you 1 second. So let's say in here, I have a string. Okay, so let's have this as an example. And this is supposed to be an option, right? You're setting up an option not at the end, but in one of the middle areas. And conventionally speaking, this should actually not generate an error because it's number string and this is optional and it's number. But you're still going to get a number because it says a required element cannot follow an optional element. So in tuple, you're better off having the optional elements at the end because otherwise um, you know your program is going to get confused. Your compiler is going to get confused. So if it's like this, so let's say the string is at the end. Okay, so at the end you can have a string, but it's optional. In that case, the other conditions have been fulfilled. We have a number at the start, we have a string at the start, we have a number at this in the second part, and then we have a number in the third part. But the last one, it can either be a string or not a string, but it can either be there or not there, but it's not there, no problem. But if you had it here, it would get confused. Yeah. Okay. Okay, and let's talk about a couple more types. So you have your any type. So if I specify a as any, that's pretty much every type out there. So you can make it uh, a number, no error, and you can make it a string, you can make it a boolean, you can make it an array, um, you can make it an object even or a function actually. So if you know functions, you can make this a function as well. And that's going to work as well. So or you can make it undefined, or there's your void. Okay, void is actually a type. So it can be undefined or it can be nan, not a number. So it can be anything and it's all going to work. So that's any. And now you also have a void. Now that's generally used to specify that there's no value. So generally your undefined comes under void. And when you're using it on a function, so let's say you have a function like this and it's not going to return anything. In that case, you can specify that the return value is void. Now I'll be talking about functions in detail, but this is how you set up a function and this is where you specify the return value. So if you're not going to have a return value, you can make that void. So that you can use void that as well. So to specify that this function is not returning everything, so it'll just stop any return. If we look at our O's, I haven't called the function. Once again, let me just quickly call it. And now if you look at it, see, it says hello there. So I think that pretty much ends most of your most of your common types. Now there are a couple more. There is your enums and you have your unions and intersection as well. So now the union and intersection, we'll be talking about that later on. And I've already talked about type inference, right? So for now, let's just move on to enums now. Okay, just a second. Okay. So now you generally use enum when you already know values. Okay, so in our example, as you can see, you have a couple of levels. You know the levels already. So there's your beginner, intermediate, expert, or master level. So if you know the values, it's named constants. So these are your constants. Okay, and you already know them. So in these cases, so yeah, 1 second. Let me look at the first. Lookup values. Yeah, something like that. So let me show you. Let me think of another example. Maybe. I don't know. So pass or fail. So let's say you have or grades. There's only A to F, right? So in those cases, so you can in cases where or the days of the weeks, names of the week days and names of the months. So all of those things. So in those cases, you can use your enum. So there's a couple of things in here as well. You can access them just like you would access a normal you know, normal array. But generally, this is how you would use it. So you'll set it up. You'll set it up with a name. You'll specify all of the constants like this, and then you can receive your enum value as if you want in one of your functions. You can receive it as an argument like this. Okay, so you can access it directly like this. Okay, level dot beginner would access this beginner, and this is how you can access it. But if you try to access it with your indices, then you will get a string. Now I'll show that in the next in the example now. Just 1 second. Okay, so we're back. So in our example, we have 4 levels. Okay, so maybe consider it for anything if you want. Let me look at. It could be, it could be the level of a training or something like that. So I'm just using this as an example. So let's say we have 4 levels. There's beginners, intermediate, expert, and master like this. Okay. And I want to use this in one of my functions. Now the function is basically it's going to receive the level, and based on the level, it's going to print a message. You can make the message, you can print the message anywhere you want. No, it's not actually value like you think it is. Now, this assignment, if you assign beginner is equal to 3, that's actually the index value. I'll show you just a minute. So, yeah, 1 second. Let me just show you. So for example, let's say. So there's a couple of ways of. So if I try to do something like this, well, let's look at our JavaScript. Okay, this is the mess you see in your JavaScript. As you can see here, immediately your it gets converted into an array. So level of beginner is equal to 0. Okay, so now these values you can change those values. I'll show them just a minute. So if I right, so that's the value. On the other hand, you can access them with their indices, so to speak. And if you look at that right now, where is it? Oh, sorry, I haven't saved it. Okay, now if you look at that right now, it says beginner. So, but this beginner is different from level.beginner. Okay, now level.beginner is your enum constant. Now, this beginner is a string. So, if you try to use it directly in the example that we'll be using, you'll get an error. I'll show you. Now, on the other hand, you can set up a starting. So, by default, it starts at 0 and it goes to this is at 3, right? So that's what your JavaScript says. It goes to 3. Now you can you can change the starting value. So if you say beginner is 1, then your JavaScript will change to, it'll go from 1, 2, 3, and 4. Now, on the other hand, you can, as you said, you can make this 3, you can make this 5, you can make this 10, and you can make this 15, and everything would, after compilation, everything would change accordingly in your JavaScript. And while accessing, you'll have to access a level of 5 like this, and it'll give you intermediate. So you can use this as you will, but generally speaking, there's no use in actually changing the index values. We can just keep it as it is. Okay, Mark, sure. Okay, so I think we've covered this part. Now, why don't we look at how to use the constant as it is. Now, instead of right now, like accessing it like you would access it, an array value would just give you a type. Now, if I try to look at the type of this particular value, then I would see that it's actually a string. Okay. Now it's supposed to be a string actually. Anyway. Oh, okay. Right now it's undefined because I've changed it. Okay, so let's go back to level 0 because it's right now at the original 0, 1, 2, 3. Now, if type of level 1, if I level of 0, it's a string. So it's not the named constant that we just created. It's not an enum value. So if you'd like to use it directly, you'd have to use it as it is. See, in which case it says number. And as we already, okay, this keeps going off, the screen keeps going off. I'll have to keep sharing it. Okay, now, as you already saw, when you just gave level beginner in here, you got the index value, right? So there are two ways to access these values. In our example, we're just going to use the direct value. Okay. So I hope that was a little clear. So let's say we have an assigned course in here. Okay, and I'm going to use an arrow function for this. Does everyone know how arrow functions works? If you don't, I can go with a normal function and then later show you how arrow functions work. Why don't I just do that? Okay, so function assign course, and it's going to accept method, and this method is going to be of type enum. So enum is actually a type. Okay, so we've created this level type. This value is going to be of type enum, and the return value is going to be void. I already talked about that. Basically, we're not going to return anything. We are just going to do console logs. So now, this level, it has 4 values, right? So one of the easiest ways of assimilating this and looking at it and finding the value is your switch. So let me get the value that I have in here. So if you have any questions in any of these at all, please ask. Now, for these cases, you can either go for 0, 1, 2, 3, which is the value, or you can go about it this way as well. So level dot beginner. Okay. So if it's beginner, now this is more understandable, right? So instead of just giving 0, if you use it like this, it's more understandable. The level of beginner is course number 1. Intermediate. We have expert. we have master. And the relevant message. So if this person was a beginner, they'll be assigned, it's just an example, they'll be assigned course number 1. If the person was an intermediate level programmer maybe, and in that case, they'll be assigned courses 2 and 3. And if they were an expert, they'd be assigned courses 4 through 7. And if they were a master, you'd probably say something like, you're the master, you don't need courses, something like that. Okay, it's just an example. And now let's assign something to R. So we have level.beginner assigned, and if we look at our output, we'd see that it says course number 1. Now, on the other hand, I can change these values and it'll work accordingly. Now, on the other hand, if I just assign 1 in here, let's see what happens. See, 1 goes to intermediate. It looks at intermediate and it says courses 2 and 3. Okay, so that's how you can access the values of your enum. And since if you try to send something else in here, maybe a beginner, a string or something like that, you'd get an error in here as well. Okay, so even though this is a beginner, you can't just send beginner like this. It says argument of type beginner is not assignable to parameter of type level. Okay. On the other hand, you can do something in here. Instead of placing the type as level, you can let's say you can say it's a string. Okay, and in this case you can access the values directly, like a level of 0. Now that's not actual convention, but you can do that. Just playing around with these things, right? And in this case, sending beginner like this, it'll work, and I'm pretty sure you won't get any errors. If we look at the screen right now, it'll say course number 1, which is exactly what we want. So 2 different ways of playing with the same thing. Okay, so that's your enums. So that took a little bit of time. So any questions? Now let's move on to functions next, if you don't have any questions right now. Oh, okay. Well, not much difference if you think about it. Now, I've just taught you the different ways of accessing it and all of those things, right? So that's pretty much it. But the main difference is that it's a constant. So you can't actually change the value of any of these, right? So you can only use it if you know all of the values beforehand. And on or in an object, on the other hand, I don't know if I showed you the example. In an object, you can change the values. Okay, if you'd like, I can show an example quickly. For example, let's say we have an object like this, and right now I'm not assigning types. Okay, I just want to show you an example. And let's say 15. So that's sorry for that. Okay, that's your object. Now you can access the object like this, and you can change the value in your object. On the other hand, in enum, it's a named constant. You can't do that. Okay. Okay, any question, guys? Can I move on to the next topic? Okay, I'll go ahead and move on, right? Yeah, okay. Okay, great. So next is our functions. Now, I'm assuming everyone knows how to create a function, right? So let me just go ahead and quickly show you how to do that. Maybe if you have no If you have any confusions on how to do it with JavaScript, you just do that. So function, it's basically a group of code, right? So you can use it to do the same thing again and again. So let's say we have a greet function, which basically greets the people. And you can, this is how you define it: function, and then the name of the function, and parentheses, and brackets, and then your flower brackets. And inside of here, you can give your piece of code, and you can call it like this. Okay. And if you run this, you'll get exactly what you asked for. So that function was called, and the message inside of that was printed, right? So now you can actually send values from this as well. So in here, you can accept values. So you can say that this has to have a message, and instead of printing a direct string, you can just print the message that was sent from your function call. Now you can change that message to anything. So every time you call, you can call it multiple times, and that's one of the uses of your function. So okay, so every time this message is going to get changed. Now you have this error in here because we haven't set a type. Now don't worry about that. I'll talk about it in just a minute. Refresh. See, so we have all the functions called. There's your hello there, there's your hi, there's your how are you, and all of those was printed because every time you call the function definition actually gets called, and the relevant message gets printed out inside of that. That's the basics of your function. Now in a TypeScript and in your JavaScript ES6, there's another way of creating your functions. So it's the same function. It can be written in another way like this. So you can use const because you're not really going to reassign to the function, right? So the function definition is pretty much the same. So const greet like this, and then equal to, and whatever argument you're going to get in here, place that there, and then a flat arrow like this, your equal to symbol, and then your lesser than like this. Okay, like this. I'll just remove this. Console.log of message. Now if I run this, it'll still work. So before ES6 came about, TypeScript was the only thing that had your arrow functions. It looks cleaner, don't you think? Actually, you can completely get rid of this if that's what you want. If that's just one line of code, you can just have it in just one line. So the entire function is just one line now. So that's your functions. Let me go back to the PPT and explain how how type checking works in your functions. Okay, so now, for type checking in your function, you can specify the types for both your parameters, okay, the values that you receive in your function definition. So you can specify that. For example, in my example, it's a concatenation function that concatenates two strings, basically joins two strings together to form one single string. And I've received the strings in here, right, in my function, separated by commas. Now, these have to be string because that's what the function is for. So I'll specify for each of these, just like we did with our variables, the same method. I'll have to specify that these are strings. Now, the only difference is that you can actually specify the return value as well. So now if there was just a console.log statement in here, then you would just place a void. You would make the return type a void. Now, on the other hand, I'm actually returning something in here. I'm returning the addition or the concatenation of these two strings. So I've just made that. I've made the return value string, and then I've called it. Okay. But if you don't return anything, if you don't specify a return value in here, based on the type of your parameters and based on what's happening inside, in which case, in this case, it is addition of two strings, your TypeScript will automatically infer that, okay, fine, the return value is probably a string. On the other hand, if there was just a console.log statement, then it would infer that the return value is probably void because nothing is being returned, right? So it will automatically infer if you don't explicitly specify a return value. Okay, so let me share my code screen now, and let's look at the example. So the same example, the same concatenation example that we looked at before. On the other hand, in here, right? How would you change this? You change this to a string and this to a void because we're not returning anything, and this parameter is supposed to be a string. So if you try to send a number in here, you're going to get an error because it's not assignable to parameter of type string. Okay, so that was our previous example. Now for the next example. So we have our concatenation function. So we have two strings in here, our string 1 and string 2. And the return value is also going to be a string because I'm returning something in here. And the return is just addition of these two. That's it. Okay. Now, on the other hand, since I've set up a return in here, on the other hand, if I try to do a console.log of string 1 and string 2, which does the same thing, yes, but I would get an error in here because a function whose declaration type is neither void nor any must return a value because we're asking for something in here, right? Now, if I return just a number, 10, I would get an error in here in the return statement because type number is not assignable to type string. It's looking for a type. So you can't use a console if you have an actual type specified in here, and you can't return another type if you have another type specified. Okay, so since I have string specified, I need to return a string. So that's one of the uses of this. With a space. Hello, like this. Now, I can assign this to and just log it to the console. If we look at our console now, see, we have hello world printed out just like we want. So that's the basics of your string number. Do you have any questions? Shall I move on to the next part? Okay. We're almost just a couple of 10 more slides, so not much. Please bear with me. Okay, so now let's look at a couple more things on functions. Okay, so just like you did with your tuples, you can make the parameters optional as well, and also make sure that the optional parameter is at the end so there's no confusion. So just like that, just like before, you have to specify your question mark right before the type specification. Okay, and you can create default parameters as well. I'm sure you know how to do that from JavaScript, right? So specify the type and then assign a value to that, so you can do that. And if you know ES6, then you must know about your REST parameters, where you can send any number of arguments from your function call, and it gets received into an array. So the only way to specify that is by using two dots like this, and then create a value. So if you only want, let's say, if you only want strings to be sent from as a list of your, even in your list of arguments, if you only want strings to be sent, then make it an array of string. your str an array of string. On the other hand, you can make it an array of numbers or a combined array, just like we saw before. Okay, so that's rest parameters. So let me quickly look at all of those things now. So there is your optional, right? Optional parameters. Sorry about that. Okay, so optional parameters. So now let's say one of those things is optional. So this is going to be optional. Now there's going to be another string in here, and we can add this. Now if I'll just do a console.log of I'll call the function within the console.log. Okay, hello world, it works. If I do a console.log, hello, okay, just an example. Okay, now all of these work. Now why? Because in here we just send two parameters, two arguments, and here we are sending three, and it's still working because the last one still a string. Last one is optional. Okay, so in your output you're going to get exactly what we need. Well, of course, not exactly what we need, because we are in fact using it inside of our code. Now, on the other hand, if you were doing real world programming, you would actually probably ask for it inside. If string 3 was present, then you'd only then you return all of this. Otherwise, you'll just return 2, because there's an option, right? Now, if you look at our output, we're going to get exactly what we want. See? Hello world, hello there. Perfectly works. Okay, so that's how you can use your optional parameters, and you can specify default as well. I don't know. In here, maybe let's make this world by default. Okay, and so, and for this, I'm not sending anything because I have a default parameter. So let's just remove the third option. Okay, so since we have a default parameter for the second one, I'll give it a space. Since we have a default parameter for string 2, we can just send a value for string 1 and it'll work. And just like your optional parameters, make sure that your default parameter is at the last. So whatever is sent is used for the first one. Okay. Otherwise, if this was here, then your hello would still be used for string. If your default is here, for example, this hello would still be used for string 1, and string 2, if it doesn't have a default, you'll get an error in here saying that no value was assigned. Okay, so we can look at the error just now. See, expected 2 arguments but got 1. An argument for string 2 was not provided, and since that does not have a default, you're going to get the error. Okay, so always make sure that your default is at the end of the list of parameters. Now, if you look at the output, you're going to get it. Hello world, hello there, it works. Now for the rest parameter, right? So for rest parameter, you can basically send anything from inside of it and it still has to work. So what I'm going to do in here is, instead of separating it like this, 3 dots, str, string, and in here we can, just an example, I'll create an empty string to start with and use the for each loop. If you have any confusion in the for each loop, please let me know. Basically, it moves through each element of the array, and everything that we are sending from our from the argument list, all the argument list is going to be stored inside of this array str, and it's going to move through each of those arguments, and for each of the arguments it's going to do something. What I'm going to do is I'm going to create an anonymous function. Anonymous function is basically a function without a name, which can be created inside of things, and here I'm creating it inside of the for each loop. So this function is going to receive each of the elements. So in value, this can be anything. Okay, it's also a parameter, right? So this would be each of the argument lists sent from here for every iteration of the loop. And I'm just going to add the current value of s to the value in the array, and finally return s. So no errors, I believe. Yes. Refresh. It still says hello there, because, and you can send any number of arguments in here. You can say like this. See, all of that works. Okay, so any questions so far? So we looked at arrow functions, we looked at anonymous functions, we looked at REST and all of those things. No questions, right? Now I can move on to the next part, which if you don't know ES6, this is going to be different for you. Interfaces. So if you have any questions, feel free to ask in the middle, okay? I'll handle that. Okay. So this is something that you don't have in JavaScript at all, and it's called interfaces. Basically, it's a contract or a blueprint, and you can use that to describe the structure of your object, class, or function. Now remember the type structure we created for our objects. So we'll be using our interface to create something similar, but the only difference is that this type that you create in here, now interfaces are types. Now this type that you create in here you can use it, you can apply it for multiple things. You can apply it for function parameters, to multiple objects, to classes. Once we look at it, you'll know. So that's the only difference. That's the main difference, actually. So we'll look at that, and as I said, you can reuse it multiple times. And just like with your functions and everything, you can make some of the properties in your interfaces interface, some of the types optional. Okay, and you can make some of them read only. That's a different thing. Okay, so if you specify read only in front of any of the properties, then it can only be read, it cannot be edited. If you try to edit it, you'll see, yeah, we're trying to edit roll number in here, change the value of roll number in here, we are getting an error, right? So you'll get that issue. In next union and intersection, we'll talk about that just a minute. So before that, let me show you an example of how interfaces work and how they can be used with your functions and everything. Okay, so what I'm going to do is I'm going to create an interface. The syntax is as follows: place use interface, it's the keyword, and the type of interface that you want to create. So general convention is you specify the type, the name of your interface with the capital letter. Start it with a capital letter like this. So I'm going to create a student interface. So then later I can apply it to multiple student objects maybe, or anything. Okay, and I'm going to specify that it can have a roll number of number. And this is how you specify the type, right? Just like you did with your object, you have to end everything with a semicolon. In your object, while assigning values to your object, you separate the assignments by commas, right? But in here, you have to end it with semicolon. And you don't need an equal to or a colon or anything in here. Just interface and the name of the interface, and then open your brackets like this. Now name is a string. Float is a string, total is your number, like this, and you can apply it. Now applying it is similar to, so let me say I have an object called student1 in here with a small s, and to apply it, just like you would apply any of your primitive data types like number, string, or anything, you can just have a colon in here and say that it's of type student, right? So now I'll have an error because I don't have the exact name, properties, and the types. Okay, so it has to be exactly the same. Now there are a couple of leeways. We'll talk about those. Like this. Right, so you can use it multiple times, right? So you can go ahead and create a student2 object and give a completely different set of values in here if you want, or you can use it in a function parameter. So let's say I have a print student function in here, and the parameter I'm accepting is an object of type student. So if I say it's student, then it's understood that it's going to be either an object or a class type. Okay. And I'm not returning anything in here, so I'll just do a console.log, or why not use, I'll just use template string. This is where it works, it helps. Roll number is student roll number, and name is total. I'm just going to print these. And while calling print student, I'll have to send an object, right? So I can send an object in here. Now, see, there's an error right now because a lot of arguments are missing. We are looking for roll number, name, sports, and total of those exact types. So roll number is 1002. Name is Susan. Sports is yes. Total is 450. And now no errors at all. See? That's how you can use your interface and reuse your interface. Now why don't we look at the output of the function alone? That's the only thing that we've printed out, right? See, it says roll number 1002. Yeah, name is Susan. Total 450. That's because it's a little skewed because I haven't really aligned it properly. So if I do it like this, it'll come in the direct line. Okay, so that's your interface in general. Now you can make one of these things. As I said, you can make one of these things optional. For example, why don't I make sports optional? Okay, like this. And why don't I make roll number read only? So just specify read only together before the name of the property, and that will become read only. So now in here, while sending the function parameter, I don't have to send sports and no errors at all. And in student1, I can try to, or I accepted this in here, right? Before I do a console.log. Now, why don't I try to change the value of student.roll number in here? See, it says cannot assign to roll number because it's a read-only property. So even after it has been accepted as a parameter, if you try to change it, you're still getting an error. And now, see, if you noticed, except for our optional value, there's not much leeway in here. You can't say, yes, you can accept, you can create objects or function parameters of lesser properties if they are optional, but you can't create more properties after this. So let's say these are the compulsory properties, but after that you might want to have more properties, right? But right now we can't. If I try to add another property in here, I'm going to get an error. because it's not in that particular interface. Now it's very restricting, right? So what I can do is I can there's this little trick that you can use to basically you're saying any property of type string. So this is of type string and the value can be anything. So basically you're giving leeway for usage of any number of any properties other than this. So these properties and their conditions, they stay the same. So if you create a name property and assign a number to that, you're going to get an error. Okay, but you can go ahead and add more and they can be of any type and you're not going to get an error. You can add anything you want and you're not going to get an error. But on the other hand, if you try to uh, sports, right, even though it's optional, it has to be of type string, right? So if you try to make this a number, you're going to get an error. You get me? Or if one of the compulsory properties like the name property, which is compulsory, if that's not there, you're going to get an error because name is missing. Okay, so the properties that you've set up already, they have to be there if they're not optional. And the read-only conditions, all those conditions matter, but you can set up extra properties as well. And now finally, let's look at finally in our interface, let's look at something. There's your union and intersection. Okay, so far, you might have seen the symbol before, right? So this is the symbol for a union, which basically means that which is or. So it can be either this or that or both. All of that is going to work, and an intersection is it has to be all of it. So now union and intersection is generally used in interfaces. It's mainly used in interfaces. So when two interfaces are joined by a union, any of the properties of the union can be used in the final object or class. When they are joined by an intersection, all of the properties of the two interfaces, they should be used in the final object or class. Okay, so this is how you these two are names of interfaces. So while you're setting up, this is how you use intersection on your interfaces. This is how you use the union on your interface. Now let me show you an example of how that works. All right, so in here, let's just get rid of all of this. Right. So in here we have this interface, right? So instead of that, what I'm going to do is I'm going to split this into two different interfaces just for the example's sake of it. So let's say this has roll number and this has string like this. Okay, just a name like this. And we have another interface, marks, with total number, just that. Okay, so in here I can which basically means that all of the properties of this have to be used. Now, if I don't use any of those properties, I'm going to get an error because one of them has been missing. So this interface will combine to create the first interface, student interface that we had. Now, on the other hand, if I used union, that means it can either be 0 or more. So if I don't have any of any properties from student detail, and if I just had total in here, that will still work because it's 0 or more. Or if I just had one of these, okay, it'll still work. Now, on the other hand, if we try to add something, it's going to be an error because it still has to be between both of those. And in this case, you have to specify any property that we had before if you want to add more. Okay. Not exactly. You can use it for we have used union for our objects, our arrays, and everything, right? So union can be used Intersection, on the other hand, you can't actually use it for you can't exactly use it for your general types because you can't specify both, right? You can't create a value of both those types. But union, you can use it in your normal. Let me show you why not. So let name union, right? So number now this is the union. I just placed this with intersection because it's easier to understand this way. So it can be 15. What? Okay. 15, and it can be hello, like this. So if you try to use intersection, on the other hand, you're not going to get anything, because if you try to combine these two, you're going to get the type never. So intersection does not work that way. So even actually, even in here, if you try to intersect two interfaces, and let's say both of them they have the same value. Okay, as long as they have the same type, the same property, but the same type as well, you're not going to have any problems at all. But if one of them has a different type, now just like you saw before, right? Intersecting a type string and a number, or any two types together, it's going to create never. Now, never basically means that there's no value at all. Okay, just like void never has no value at all. Okay, so you're going to get an now, right now we are using our union, so you don't see the difference. But if I use an interface, you're going to get an error because the type number is not assignable to type never, right? On the other, okay, right. So I think that that concludes interfaces. So let's move on to classes next. Okay, so if you have any programming background at all, you must know classes. And in JavaScript, if you've come across ES6, then you must have come across classes as well. But JavaScript classes, they are not comparable to TypeScript classes at all, because uh, frankly speaking, JavaScript classes are more like syntactic sugars, which have been built over prototypes. They do certain things. Yes, they can be used to create multiple objects and a couple of things like that, but they don't really do much that a true OOP language does. Okay, so you don't really have any of those true benefits. Now, TypeScript corrects that. Okay, so you have your classes, you have inheritance, you have access modifiers, you have proper getters and setters, and not just creating getters and setters just like we do with JavaScript. In here, we actually have getters and setters which can actually be used the way they were created to use, and not like functions like we use in JavaScript. Okay, so this is how you create your classes. Okay, so class, the name of your class, and just like with interfaces, the general convention, if you don't do it like that, you're not going to get an error. But general convention is uh, started with a capital letter. And before you start, everyone in here has an idea on classes, right? So I don't have to explain how classes work, right? Yeah. Okay. In that case, I'll just go to the TypeScript part of it. So the only difference, the main difference in here is you'll have to specify the type. Okay. If you don't have, specify the type of your properties to start with. You can also and then when you use it in your constructor, now these are the values that your constructor receives when a new object instance is created. So you have to specify the types as well. So these two have to match. Okay, now this roll number is not this roll number. Okay, this roll number is in here. Now this roll number is the original one. So you can name this just R, but make sure that the type is the same. Okay, because we are assigning it, right? So the type has to be the same. And then this is that particular object instance. We are assigning the value. And finally, you can create a new object instance. And if any of these types don't match, you're going to get an error. And you can create methods as well, just like usual, and you can have parameters inside of those methods and specify the type. You can have the return type specified as well. If you don't specify it, it's going to be considered any. That's just your normal class. Let me just look at an example of that. So the same example, let's just type it out and see how it works. So we have our number. Roll number is a number, name is string, and total is number. Right now we're getting errors because we haven't actually initialized any of these to the constructor. See, immediately, since we specified this as a class, it's immediately asking for initialization and an assignment in a constructor. Constructor. Right, and you can create a method if you like, and in a template string. I'm not going to explain all of these. It's if you have any doubts at all, please ask. Right. Mm, there you go. And finally, you can get marks from the students. You can create any number of object instance just like you would normally do it. And if you look at the output, say it says John has scored 490. Right? So if you try to change any of these things, if you try to send a string in here, you're going to get an error because it's not of the type. And as I said, these are not the same. So you can have it change, but just make sure that both are of the same type. So if you try to assign a string to a number type, you're going to get an error. And that's it. So now let's look at interfaces with classes and a couple of other things. So we can quickly move on to the since you already know how these work, okay, I'm just going to quickly show them and then show you examples of it. Okay. All right. So classes, interfaces. Now, remember when we talked about interfaces, I told you that you can actually specify these implement these interfaces inside of your classes as well. Okay, so it's pretty much the same, actually, the same method. Um, specify your types. You can also specify a function type for the method. I'll show you that in the example. And then just make sure that all of that is implemented inside of your class. Now, if you try to do more, you're going to get an error. So if you want more, you'll have to use the any type that we created before, right? So that's how interfaces work. I'll show you example later on. And you can use the same interface for multiple classes. You can create a student's class. If you can create a college student class, a high school student class, maybe. So you can use it for multiple classes. And now for inheritance, now remember if you know classes, you know inheritance as well. So inheritance is basically you're inheriting from a parent class, just like we inherit from our parents. So you can inherit from one class like this. So basically you can use all of the properties and methods in the class, and you can also create your own properties and methods in the child class. So you have twice as much benefit. Okay, and you can inherit from multiple classes as well, or you can create it so that class marks inherits from student, and you can create another child class that inherits from marks. So this new child class will inherit will be able to access the properties and value and methods of both marks as well as students. Okay, before we get to method overloading, okay, let me talk about that as well. And there is inheritance. Okay, there is something called method overloading, right? Where you're both your parent and child classes. They can have methods with the same name. And if you want to use access the parent method, then you'll have to use the super function. We'll talk about that when we look at the example. And if you want to access the child method, you can just use the object that you created the class with, just like you would normally do it, right? Like this. The super dot method name would access the same method inside of your parent, the object name. Now, this would only work inside of your function, okay? The object name dot method name would by default access the child method, okay? But inside of your child class, if you want to access the parent class, you can use this. Parent method, you can use this. Now let's look at some examples. Once we look at the example, I'll ask again if you have any doubts, you can let me know. Now interface, right? So we can have interface. I'll create an interface for the class that I just created here. Okay, so you can do it in any way you want. And for functions, it's pretty much the same. The name of the function, it has to be the exact name. Okay, so exact name of the properties, exact name of the function. If you change any of those, then it'll say this is not available, or this if you make it just role O, then it'll say property role O has okay, it's okay, let's say we do it like this. We haven't implemented that yet. One second, let me show you. So in get marks, I'm going to use my arrow. And in my example, there's no parameter, so it's just going to be empty brackets. If there's a parameter, you'll have to specify the parameter type in here as well. So for example, let's say we get a string in here like this. Okay. If you get a string in here, then you'll have to specify that this is supposed to be a string or something like that. Yeah, something like that. Okay, so the first argument, let's say a string. So if there are more arguments, you can specify more arguments, and you can specify the type of those arguments inside of your interface. And the return statement. So if you were returning a string, it will be string, and if you were returning nothing, it will be void like this. Okay, and to implement it in here, instead of using your colon like you would with the other examples, you'll have to say implement and student. Now I have an error in here because it incorrectly implements interface because property role number is missing. Remember what I told you? So if you don't specify the exact name, it's gonna consider that the particular property is missing. Okay. All right. So that's how you can implement your interfaces. You can use all of the things that I taught about interfaces in here. Okay. And for inheritance, let's say we have this, right? We have our students here, right? And now let's create another child class in here called marks. Now to inherit from something, you have to use extends and the name of the parent class. And let's say I have a couple of things in here. I'm not implementing any interface in here. You could create an interface for this and you can implement that here as well. That would work, but I'm not going to do that now. You know how to do that. So but in the constructor, since we are implementing the students, we have to, while we create an object instance with this, you need to send values to this constructor as well. So you need to accept you need to accept values for this, okay, these original values, as well as the values, as well as the properties you set up in math. Okay, so you have to accept 6 properties now. And to start off, you can just call the super method, which would call the constructor function of your parent class. And we're going to just send off the methods that we can't handle, the properties that we can't handle, which is roll number, name, and string, and total. See, it's asking for the same because it knows. And then later just assign what you have. Like this. Okay, and now you can create new marks instead of new students, right? And this is going to be it. You have an error because you haven't sent a lot, so you can just say 100, 90, 90, and you can make the total 280 to match up for it, right? And if you do a get marks right now, so basically you can access anything from here. So if you student one dot get marks, which is actually inside of your students class, that would still work because it's, see, John has scored 280. On the other hand, you can access the values inside of this as well. So you can say student one dot math, and you'd get 100 accessed. Right, now let's look at the method overriding that I talked about. So we have our we have get marks in here, right? So what I'm going to do is I'm going to change it in such a way that it returns something. So I'll specify string in here and also in the interface, so no errors. Right now we've specified that it's void. Let's change it to string. So specify string in here and return. Okay. So in your child class, if you have a method right now, when you access get marks, you're actually accessing get marks of your parent, right? But if you have get marks, a function of the same name inside of your child class, on the other hand, right? Let's see what happens now. Let's see how it changes now. So let's say for now, for as an example, let's just make it this, okay? And in here, let's wrap a console.log around the function call because we are returning something, right? And let's look at the output. See, the function call has been overridden. Okay, even though your parent class does have the same name, a function of same name, then if you're creating an object instance of your child class, then you're just going to access the function of the same name in the child class, not the parent class. On the other hand, if you'd like, you can do something like this. What you can do is, I'll create another um, you can use the super method within. You can't use it outside in here. Okay, so if you try to use the super method outside, you're going to get an error because super method is mainly for, it can only be referenced in members of derived classes or object literal expressions. Okay, so you can only use it inside of your child classes. Okay, so you can use the super method to access this method and then have the rest of it. Hmm. Oh, sorry. Yep. If I look at the output, see now it has asked for the parent method and it's accessing the rest of the message as well. So that's method overriding. And now finally, let's look at our access modifiers. That's the last topic in our classes. I think we're at the end of it. Just give me like 10 minutes or so, then we'll finish this. Now, so there's see, this is something that's completely different. Now, this is something that's mainly used in your OOPS languages and something that your JavaScript doesn't really have. So which TypeScript helps in applying to your web applications. So you can specify access modifiers. The main access modifiers are public, private, and protected. And as the name implies, you can use it to change or limit the accessibility of your methods and your properties. Okay, so your default modifier is actually public. Okay, now so far we've been creating a lot of methods and our properties, right? And all of them have been public so far, which means that they're accessible from anywhere, from your child classes, from outside your class, directly by using your object instance, your object name dot, like, right? So you can do that. So that's your public. So on the other hand, if you have to explicitly declare a property or a method as public, then you can use the public keyword and then the name of the property or method, and then you can specify the type. Okay. And then you have your private modifier, which is not accessible from outside the class at all. So if you create an object instance of a particular class and if you try to access a private property, then you're going to get an error. And of course, you can't access it from inside of your child class as well. And then finally, you have your protected property, which is similar to private, but the only difference is that it can be accessed from your child class. But of course, it can't be accessed from outside the class. If you do that, you're going to get an error. And finally, this is not this is not one of the major access modifiers, but it's also a modifier. It's a read-only modifier, which make the properties and methods read-only. We've already looked at that before. And also you can, I'm not really sure if you're seeing this, but you can specify not just read-only. You can make a particular property both protected. I mean, you can specify any of the access modifiers, and after that you can specify read-only or any of those things. And there's a small error in this. I'll correct that. Where is that? This one. Okay, so I just made a small mistake. So it's protected and roll number. Okay, so you can specify it as a protected or private or anything, but that has to be that has to come at the start and then read only. So which means that this particular roll number property cannot be changed, but it cannot be accessed from outside the class as well, but it can be accessed from the child classes. That is the meaning of this entire line. Okay, so that's your access modifiers. Now let's quickly look at some examples of that before we move on to the rest. Okay, so we have this already, right? So in here, let's make roll number protected, and oh, sorry, I've placed it inside of the interface. Okay, protected, and let's make name public, and let's make total private. We are going to get a lot of errors now because okay, I'm going to remove the interface. It'll keep saying it's incorrectly implemented. Okay, so we're going to get a couple of errors in here because this is protected. This is private. Have we accessed it outside? No, right? Okay, no, that's fine then. Okay, so now remember, our roll number is protected, right? Which means it can't be accessed from outside. So if I try to say student1 dot roll number, I'm going to get an error in here because it's a protected property. Now, what was a private property? Total was a private property, right? And again, it's not going to be accessible. Now, on the other hand, name can be accessed because it's a public property. Okay, but but let's say in this particular example, I try to access this dot. Generally speaking, I should be able to access this. So this dot, see, we have a couple of things in here. So we can access chemistry, physics, and math, which was created inside of my child method. But I don't see total in here at all, which was one of the properties of my parent class. There was name is here, name is public, it's here. Roll number is protected, which can be accessed from inside of your child class. So it's here, but total is not here because it's private. So if I give total in here, it would say property total is private and only accessible within the class student. Okay, if I make this get marks private, now, in that case, the entire thing is going to be a problem. We can't use the super method on the get marks either because it's private. If I make it protected, on the other hand, it's going to work. If I make it protected, then no error. The only error is with our total, right? Right. Okay, so that's one of the examples. And of course, you can make any of these read only. Remember, I said you can make it read only. And what was this? This was protected, right? This was protected read only, right? So inside of my get marks, before I return something, if I try to, let's say, just an example. Now, if I try to do this dot roll number, now accessing it is not a problem because it is just protected. But if I try to change that, I'm going to get an error because then you cannot assign to a protected property. And the same goes even if this was public. Okay, if you try to change it from outside the class, you're still going to get an error. Now, now one more thing I want to look at is, getting rid of all of this. Okay, so you can actually get rid of this, and you can, if you're using the same name for your property and the value you're receiving when you create an object instance, then what you can do is you can just get rid of this, but and specify all of that inside of the constructor directly. But the only condition is that make sure that the names are the same. Okay, so this has to be roll number is equal to roll number that, and also make sure that you use an access modifier, either a read-only modifier or one of the three access modifiers. Okay, so if you don't specify your property with that, you're gonna get an error. Like this. Okay, but if you don't specify any of these modifiers, if you use it like this, you're going to get an error that says property roll number does not exist on type students. It'll just say it does not exist because it was expecting a specific declaration beforehand. Okay, so if you want to save some lines of code, you can do it like this. And instead of this, you can just specify read only as well, in which case now roll number has become public because that's default, or protected. If you want it to be protected read only. Access modifier comes first always. Okay, so that's your modifiers, and then let's look at our getters and setters and static properties. Now, so getters and setters, it's just another way to restrict access to your properties. Okay, you can create hidden properties that can only be assigned values via setters and accessed via getters. Now I'll show you an example of how this works. There are 3 steps. First, you have to create the property that you want hidden as a private property. And then while you're instantiating that property, you wouldn't send it over in your constructor because you're going to create a setter to assign value to the property later on. And you can create a getter that can be used to access the value of the property later on. Okay. The only this would be the only way of accessing the property. And before we look at the example of getter and setters, let's look at static properties as well. Now, uh, so far all of our properties and methods, they have been for that particular instance of that particular object instance that you create for your class. Now, in this, but with static properties, you can create properties and methods that are common to the entire class like this. Just specify static before your property name, and that would become a static property. And to access them, you'll have to use the class name, you know, outside of your function. So like this, outside of the class like this. So if your class name is students with a capital S, then students.school would access this. Okay, so it can't be accessed via object instance, via the name of the object instance. And you can use modifier on your properties as well. So the access modifier comes first. So your public or private protected, it comes first, and then static comes, and read only comes last. Okay, so this basically says that this can be accessed from outside anywhere, and it's static, which means you have to use your class name, and it's read only, which means you can't change the type. And similarly, you can do the same for your methods as well. So I've created something called get school name, and I've made that static, and that's pretty much it. And you can access that with the name of your class as well, right? We're just left with namespaces. Now, quickly, let's just look at the example of this, and let's in after which we can move on. So remember our class students. What I'm going to do is I'm just going to completely delete the child class that we had before. We're just going to stick with my student class. And what I'm going to do is I'm going to try to hide the it's already private, but why not? Try to hide our total class in here. So I'm going to just remove this. And for this example, we don't need our method. Okay, so to create your getter and setter, you will have to first create a private property, and the convention is to specify the private property with an underscore at the start. Okay, like this. Forget the errors. That's not problem. And then you know your getter and setter, these are actually functions. Okay, you can use them with these you have to set them up as public. You can go ahead and not set it up, it's default, right? But it's up to you. So to set it, you can use the set keyword, which means that this is the set method, the total set method, and it has to accept a value, which can be anything, but mine is going to be a number. And then you can assign the private value that private property that we just created to the value that we just received in here. And getting it is similar. We're not returning anything, we're not accepting anything, but we are returning the private value. So now you'll notice that since this is private, it can't be, if you create an object instance, if below here, let's student1 is equal to new student, was it? Students 1001 and John. Now we just need 2 in here because that's all our constructor is expecting. Now in here, if we try to access student1, but this was the property that we created, right? So that's not accessible. It's private. But and we aren't actually instantiating with the original while creating the object. So when we need it later on, when we need it, we can use the total value, but you don't really have to call a method inside of it and send it. Okay, you don't really have to do it like that. Since it's a set method, you can just say student1 dot total. It'll act like a property, and you can assign whatever you want in here to access it. Student1 dot total, and it'll call the get method. Okay, and it'll return this. Okay, doing this assignment will actually call the set method, and this value that you assign to it, make sure it's a number because otherwise you'll get an error because we've set it up like this. So this value that you assign to it is going to be put in here, and this value is going to be assigned. This dot underscore total is going to be assigned. When you try to get it, it's going to get it for you, right? Now, static property, let me go ahead and do that as well. Static school string ABCD school, and see, to access it, you'll have to use the entire class value like this. You can't use this. That wouldn't, you know. And if you want to access it from outside, you'll have to say students dot get name. Refresh. So first one is 480. We were asking for the total, were we? Let me just check. Yeah, we were asking for the total, and that says 480. And the second one, don't have to have a console.log around this. There you go. See? Perfect. So that ends your classes. Now, after we finish with namespaces, I think we are done with this class. So if you have any questions at all, please ask me, or I'll move on to namespaces for now. Okay. So now namespaces. It's just a logical grouping of functions, classes, or interfaces, or it could be all of them, or it could be any of them. Okay, so basically, if you say in my example, I've created a namespace called greetings. So any function or class or anything that has to do with greeting, I'm going to put it in here. So if I have a function, if I have a namespace called addition, so anything that adds numbers, arrays, or strings or any of those, I'll put it inside of it. So that's how namespaces work. It's basically used for you know to group things together so you can use it later on. Now make sure that namespace, the scope, it's within the namespace. So if you don't export it, you'll have to use this export keyword. Even if the namespace is within the same file, you'll have to use the export keyword to export it outside so you can use it. And to use it, you can specify the name of the namespace and then dot the function name or the class name or anything like that. It goes like that. Okay, that's how you can specify that. And if you have a namespace in another file, which is the general convention, okay, you generally use namespaces so you can have a list of generic functions, maybe list of general interfaces or classes, maybe, and you can import that into all of the files that you use them in. And to import that at the top of your current file, just specify this. Okay, specify the path, and then you can use it just like you would use a normal namespace. So for our example, I'm just going to create a namespace within my same file. Later on, you can try it out in any way you want. Okay. Have I talked about compiling? Okay, that's one thing that I missed out on. So compiling a file with namespace is different from that without namespace. So if your file has namespaces, or if it's just a file of namespaces, what you would do is, to start with, you'll have to first convert that into a JavaScript file, right? So tsc.cmd two hyphens out file, and if it's namespace file .ts should be converted into your namespace file .js. Okay, in our example, our ts code is going to be combined with namespace, so we'll have to use the same compiling command for the main file as well. Okay, Generally, if you had a separate namespace file, then what you would do is you'd compile it like this to create your JS file, and then you can use the reference path, and then you can normally compile your normal file. Okay, normal TS file. Okay, so in our example, so just normal functions, I'm going to right. Don't think too much about this. You can just use it in your later on based on what your example is, what your need is. I'm just creating some examples to show you how it works. So to access it, you have to first export it, otherwise you wouldn't be able to access it. And then greetings dot the name of your function. As I said, just an example. Now, what I'd have to do is forget those errors. Now I'll have to terminate this current batch because this wouldn't work for namespaces, and tsc.cmd hyphen hyphen out file like this. And the name of my file is sample.ts, and compile it into sample.js, please. Okay. Has it been compiled? Yeah, I think so. If we look at the output right now, should work. There you go. Hello world. Hello, how have you been? Right. So that was the output. So the main use of this is having it in another file and using it in multiple TS files in your real world project. So there's something else of the similar vein called namespace, but we'll be looking at that tomorrow in our Angular session because Angular is full of modules and components. Okay, so that actually concludes our session. So you have this project to do for this particular session. It's a very simple project. I need a student details form, you know. So just build upon the example that we've been using throughout the session. Okay, so create a student details form that gets your student details. So you just use the similar, DOM properties that you have in JavaScript. Okay, so if you don't know JavaScript, please look it up. So create a couple of input files, input text boxes, and with your roll number, name, total, and everything, and make sure that you specify the type of the properties. Okay, and receive the information and place it in an array of objects so you can access it later on. And you can use the usual JavaScript DOM methods to do that, and use TypeScript's type checking to the max. Use classes with their access modifiers to restrict access to information of your choice. And so your page should have two sections, one to inject information into the student I can't really see this. One to inject information into your students array, and another to get information from the array. Okay, so just some examples. Can you use union or intersection? I'll take questions now because the class has ended. So can you use a union or intersection interfaces with a class or implement? Definitely, of course. The same thing works here as well. Any more question before we end the session? So if you have any questions, please ask. It's a little bit over time, so we have to end the session now. Okay. Thank you, Jane. Thanks, Aaron. Um, no, not two pages. It can be on the same page. I'm just two sections, maybe. Like uh, you can inject input the value on the top of the page, and then in the bottom of the page you can print it out while they ask for the values. For example, if they ask for name, you can print out the names of the students. Okay, guys, I think there's no more questions, right? So I really hope you enjoyed the session. So please please fill up the feedback form. I'll see you all tomorrow. Okay, thank you. Thanks a lot.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.